All right, we're going to take a look at axis of symmetry and vertex with technology. It says find the coordinates of the vertex. Oh, that's easy. So we're just going to copy and paste. So Control C and then Control V. All right, make sure it has copied in what you need to see. It has. And then we're looking for the vertex. And what's the vertex again? The top of the N or the bottom of the U. So -5, 3. And it says that it wants it as a coordinate, so we're just going to put it in as a coordinate, -5, 3. All right, select a form to find the quadratic feature. Now, it doesn't really matter because we're using the calculator to do this. I'm just going to, I'll do factored form, okay? It doesn't matter which way we do it. So it says, you must find the y-intercepts. Write down the answers in the form of xy. You form the quadratic function, and you'd like to see in order to answer the... Okay, so it's asking what the y-intercepts are, and you can choose which one you want to do. Standard form would be the fastest to find the y-intercepts because the last number is on its own. But again, because we are using Desmos, and I'm showing you how to use Desmos, it doesn't matter which one you pick. You're going to Control C, and then Control V. And then look for whatever it's asking for. So in my question, it's asking for the y-intercepts, right? So I'm going to zoom out so I can see. It has a y-intercept of -15. So there is one y-intercept, and it is -15. Okay, I'm going to get this one wrong so I can see what other questions it asks you, because obviously it keeps changing the question. So since I only have one to get, I'm going to get this wrong so I can see another one. So that's how you do a y-intercept. Let me see what else they'd give you. You must find all the intervals where it's increasing. Okay, so it does get a little bit more challenging. So again, the same thing, the different form doesn't matter. So I did factor before. Let me do vertex this time. Again, Control C and then Control V. All right, then make sure it copied what it needs to copy. So go ahead and fix what needs to get fixed. Make sure, double check that it is what it is on there. It is. Now I'm looking for when it is increasing. All right, so if I start right here, what's happening to the graph? It is going up. Gets to the top, and then what happens? It starts going down. All right, so it's increasing, and I'll just mark this. So it's increasing in terms of like, it's increasing from here all the way to, all the way to there. And what's that number? It stops increasing here, right? And then all the way this way, it's increasing because it's coming from -infinity. So this is from -infinity, which is open because that's not a number, to whatever number this is here. All right, so if I zoom in on the vertex, which is 5. So all the way to 5, it is increasing. So -infinity to +5, open and then closed. -infinity to +5. It is increasing. If I was looking for when it was decreasing, then it would be from 5, because it starts decreasing right here, right? From 5, and it goes down like this. It decreases forever in this direction. All right, I'll do another one just again in case this changes. So I'm going to go ahead and get this one wrong too. And there's 2 different ways of representing it. So this is interval form. You'll see that you can also do it as an inequality. Is it not letting me do it? You sure you want to show the solution? Yes. I don't understand. I'm just going to go through show examples because I will talk about all of them. Okay, so this one is finding the x-intercept. So again, you copy and paste. Doesn't matter which one. They choose factored form, but it really does not matter. All right, so copy and paste, and then you're looking for x-intercepts, which is at -3 and 1. -3 and 1. All right, next example, when is it decreasing? So again, doesn't matter which one you pick, so you take whatever equation you do pick. I've already done one of these, but I'll do another one because I think you guys struggle with this one. -49. All right, make sure you copied it, whatever it is, and it's when is it decreasing? So when is the graph going down? Again, I can't tell what the graph is doing, but if I press this home button, oh, never mind, that didn't help me. I'm going to zoom out. Oh, I must have copied the graph wrong because that is not a quadratic. All right, x plus 1 squared is because I have this x plus 3. All right, perfect. All right, so when is it decreasing this time? Okay, so when is it decreasing? So it's decreasing here, right? This is all going down. All right, so you're going to look in your x-axis as when is that happening. So from here, which direction am I coming from? Negative infinity all the way to whatever the vertex is over here. All right, so negative infinity to whatever the vertex is, which is 1. So negative infinity to 1, or everything less than under 1. Okay, it looks like that's all the questions that you can get. Either finding the x-intercepts, the y-intercept, which is right here, or whether it's increasing or where it's increasing or decreasing. All right, so that's that. All right, select a form to find a quadratic feature. I think that's the one, actually. That's the one we just did. Find an increasing and decreasing domains. So we just did this in the last one, but we'll go ahead and do it again, just because I want to make sure that you're okay. All right, so when is it increasing? So it's increasing here up to where? Up to there. So where am I coming from? I'm coming from negative infinity. So this is where it's increasing, right? Up to here. It stops right here. All right, so come down to that number. It's -5, right? And I need everything below that. So I can write that as an inequality with everything less than -5, or I like using set notation. It's up to you, doesn't matter. It's coming from negative infinity, so it's going to be an open and closed. So it's coming from negative infinity, and then it stops at -5, and we include that because it's shaded. Okay. So increasing or decreasing is just you're looking at where is the graph going up, where is it going down, and then you're writing in the x values for those points. All right, parabola A value. This one's actually pretty easy if you just have to remember it. So the smaller the number, it's going to be opposite. The smaller the number, the wider the graph. So for example, if the number is 1 and I have a graph like this, if I have like a half, it's going to be wider than this. It's going to be wider, right? So the smaller the number, the wider the graph. Okay, with that being said, you have to arrange these. So I would first start with, first of all, if they're happy or sad. They're all sad, so they're all facing down. That doesn't help me. All right, so then now look for the smallest number. It's going to be the widest graph. So this is the widest graph, right? That's going to be the smallest number. All right, so if I drag that to the smallest number because 0.25 is smaller than everything. The second, oops, I didn't grab it. The smallest number, the widest graph, okay? Then the second smallest number will have the second widest graph, I guess. Or we can do the largest number will have the narrowest graph, whichever way you're going to look at it. So this is the largest number, so ignore the negatives. This is the largest number, so it should have the thinnest graph. Okay, I'm going to do another one because I want to make sure. Okay, so I'm going to get that wrong, so I can do another one. All right, so again, we're going to start with the smallest graph is opposite, right? The smallest number is the widest graph, widest. So find the widest graph here. This one's the widest. We're going to put that there. All right, notice all the negatives are telling you is whether they're happy or sad. These are both sad. This is happy, so it was the only one it could be anyway. All right, then you can do the largest the number, the thinnest the graph. So which one is thinnest out of this one? These, okay? I'll do one more, so let me get that one wrong. Next. All right, so let's start with positives and negatives so that it's easier. These are both unhappy, and this is happy. So the only happy one is this one. So now it's between these two. Again, the smaller the number, the wider the graph. So now I'm looking at these two graphs. Which graph is wider? This one is wider, so it'll be that way. Okay, hopefully those three questions were enough for you to understand the concept. The smaller the number, the wider the graph. The larger the number, the thinner the graph. All right, transformations is relatively easy to do even without cheating it. Like for example, this is outside. It's outside, so it's supposed to be y and regular, but negatives are opposite no matter what. So that's a flip over the x. Okay, and then this does what? It's inside, so it's going to be opposite of what you think. It's x and opposite, so I would think go to the right. I mean, go to the left because it's negative, but I'm really going to the right one. All right, so that's really what the transformation is, but again, we're cheating, so all we're going to do is copy and paste. So let's copy and paste, get rid of everything else. All right, and then you're going to look for the points that you started off with. So if I hit start over, I'm going to look at this point here, 0, 0, right? The bottom of the graph. Where does that bottom of the graph go? So I'm going to have to like zoom in here so I can see. All right, the bottom of the graph is going to go to 1, 0. So we're going to make sure the graph is right there, right? Then we're going to look at what was the other point right here. It was negative 1, 1, right? Which was, and you know what? Actually, we're going to have to put the original graph is. So this is what? X squared, right? Y equals X squared. So, well, actually, you know, you might not be able to cheat with this because I'm trying to think how you would cheat with this without knowing that you, well, okay, let's just say this. You know that you're flipping, let's see if we could do it that way. You know that you're flipping the graph, so let's flip the graph. So this is at 1 here, we're going to put it to negative 1. All right, so you definitely know you're flipping the graph. Then you know you're going to move it to the vertex on this graph, which is going to take it right here. And then you're just going to double check the points to make sure they lined up. So you got a point right here, which is true. You got a point right here, which is also true. So yeah, so I guess maybe you just cheated by looking, I guess. I'm going to do another one just so I can see if, you know, that changes. If you don't know the rules, if that's still okay. All right, so, oh, I guess I want to say, let me get it wrong. Submit answer. Submit answer. All right, so it doesn't, oh, it only, there's no other one. Oh, okay, it was only the one question. Okay, well, it doesn't give me a choice then. All right, next one, factor the trinomials, factor this completely. Okay, so we talked about this in class, but just in case you forgot, once again, Control C, Control V, come back and clean it up. And factoring is one step out. So when you plot the graph, remember to bring the graph into view, press this house key, whatever, it brings it back. So your solutions are -3. All right, so I'm going to write -3 is right there. And then the other solution is, what is this? -0.3, 0. And it's a repeat in decimal. So remember, you got to let it pass the first one and go to the second one. So these are my two answers. To write my answers, okay, so remember we talked about having two parentheses, one with each one with an X, and then you put the opposite of your answer in there, right? So if this is -3, this would be what? +3. So this is the additional step you have to remember if you're going from solutions to factoring. This one will be, this is -1/3, so this will be what? +1/3. Now, remember, you cannot leave it as a fraction, right? So what you have to do, or all you have to do, is take the bottom, the denominator, and put it in front of that x. So it'll be 3x plus 1. And you're done. All right, so 3x plus 1. All right, so that's the answer. I'm going to get one wrong just so I can do another one. Or you could do all of this if you want to, whichever one's easier. All right, copy, Control C. And then paste, Control V. Get rid of everything that's not that. Make sure double check your answers. Yes, it is. All right, let me go ahead and set up my solution. So we need parentheses with x's inside. Then you need to go find your solution, which is -1.8. Also, we got to be careful with these because if it is if it doesn't give you all that information, you're going to have to do it by hand. So one solution is 1. So that means this one is going to be a -1. And then another solution is -1.8. And I'm going to see if this is going to be right or if it was a repeat in decimal, right? So we're going to check it. But I don't think this is a repeat in decimal. I think we're good. So again, you're changing the sign. So positive is going to become negative. And then negative is going to become what? Positive, right? But before we put that in, we're going to remember that we take the bottom and we take it to the x. So this is going to be 5x plus, because it changed from positive to negative, plus 9. All right, so we're going to check that out. So 5x 5x plus 9. So